So in the last video, we worked with a context where we found the probability associated with a value that wasn't on one of those nice standard deviation lines. But I seem to remember when we were working with the empirical rule that we encountered it kind of reverse, right? We were being given the probability and we needed to find the observation from the population. Okay, so how do we do that? And so here's an example. We have same context, digit ratio. Okay, you're probably getting sick of digit ratio, but nevertheless, we're here. What is the 90th percentile for male digit ratio? So the idea here is if I draw a normal density curve, okay, the idea with the percentile is that it is a position on the curve such that, okay, let's call this x. Actually, I'll call it little d, okay, because it is an observation, not a random variable. But below that observed value is whatever the percentile we're at. So this would be, the 90th percentile. This would be 0.9 of the area, or 90% of the area would be left of that observed value. Okay, we could write this as a probability statement as probability that the random variable d is less than the observed value of d is 0.9. Okay, so I want to find this value. Okay, but again, it won't fall on a standard deviation line because, well, no matter how you work it, it's not going to shake out to give you 90% with those standard deviation lines. Okay, so then we go to our flow chart, right? We've seen this. Read the problem and draw diagram. That is good. Okay, and so now I need to back up and say, what am I given? Okay, I am given a percent or a probability, and I need to find a value, right? An observed value. So I want to find an observed value. I'm given the probability or proportion. So then here's the command that I need to use. Okay, norm.inv, norm inverse. Okay, and then we'll insert the probability, mean and standard deviation, no true with this one. Okay, so here's the command that I would use. All right, so let's hop into Excel and calculate that quick. And here's our handy dandy Excel sheet. So I'm going to do norm.inverse, norm.inv. Probability was 90th percentile, right? Okay, not to be confused with the digit ratio. The mean digit ratio was 0.95. Standard deviation was 0.03. Oops, 3. And boom, we got 90 or 0.988. Now remember that we can't change this into percent. This is a digit ratio. Okay, so let's capture that result. All right, and so that value of D that, if I'm looking, or that D was 0.98845. So again, we could fill it in as probably that the random variable is less than 0.98845 was equal to 0.9. Okay, 90th percentile. Okay, and so we're going to do a few more examples, but always with these scenarios, make a quick sketch. Okay, so with part B, okay, I make my quick sketch. 20% of males have a digit ratio above what number? Okay, so now I'm looking for 20%, right? That's going to be the area, but where is this? Above what number? So what I'm thinking is that this 20%, I'm looking for a value for which above it is 20%, right? 0.2. All right, so now this is unlike the first one, right? 90% was below. This is to the right. Well, wait. If 20% is above, isn't there 80% below? So instead, if you're looking for area if you know that the area to the right of a value is a certain number, you can just do, 100 minus it, find it, or use its complement. Okay? So what I'm going to do here is I'm going to use norm.inv of 0.8, and then continue to use the mean being 0.95 and 0.03 for the standard deviation. Okay? All right, so let's calculate that, and we'll hop into Excel for that. In Excel, I do norm.inv, 0.8, 0.95, oops, 0.95, and 0.03 for the standard deviation. Okay, so I get 0.975-ish. 75-ish. Okay, and again, as a probability statement, I could write this as probability that the male digit ratio is less than 0.975 is going to be 80%. Okay, or equivalently, you could do 1 minus p of is zero point 0.2. Okay, either one works. With C and D, okay, these are going to be a little tricky. I want you to pause the video as soon as you have a blank sketch for each of these, okay? And with your blank sketch, try and reason out where or how you would represent these values. Okay, so for the first one, if we're looking at, so we want to find the largest value of the smallest 25%. Well, the smallest 25% is going to be down here, right? And actually, it's quite a bit more. It's kind of like there. So in this range, right, if this is 25%, we're looking for this value of D. Similarly, in part D, the smallest male digit ratio for the top 5%. Well, that top 5% is over here, right? And so in this range, what I'm looking for is the smallest of this range, so D here. Okay, this is why a sketch is so important, all right? Because then, it, despite suffering through the language, once you get the picture, then I think it goes quickly. This one you can do norm.inv of 0.25, and then 0.95, and then 0.03. This one, if this is, your 5%, then this would be 0.95. So Excel knows how to compute to the left. I should do equals here. Norm.inv of 0.95, 0.95, and 0.03. Okay, and you can calculate these in Excel. Doing so, you get 0.93-ish for that one if you round a little bit, and then this one you get 0.999. Okay, so there we go. And then again, probability statements, this would be P of D is less than 0.93 is 0.25, and similarly for this one it would be probability of D being less than, or actually bigger than 0.999 is 0.05. Okay, just kind of reframing that. You could write this a few different ways as well. Okay, but big idea here is translate the prompt into a diagram, get a solid diagram, and then with that, that should help you determine, what you're given and what you need, and how to kind of work your way through this diagram, or this flowchart, I should say, for finding probabilities and observed values with the normal distribution using Excel.